All right, so to do this integral, we're just going to put in our velocity function, which is 13.2 sine of 2t dt. A useful thing to do in an integral like this is factor out any constants that you have, which I just failed to do because I was talking about it while I was trying to do it. 13.2 integral 0 to pi of sine of 2t dt. All right, then we're going to do antiderivative of sine of 2t. So there's a good chance to investigate like this kind of antiderivative, like what it has is it has this inside function. Now there's a formal way to handle that, which I'm not telling you yet. But first, you can figure out pretty easily what this antiderivative has to be, because I know what the derivative of negative, so like if I think the antiderivative of sine would be negative cosine, right? So first, forget about the inside function. What's the antiderivative of the outside function? All right, it would be negative cosine. So the derivative of negative cosine, but I'll keep that inside function the same, the derivative of negative cosine of 2t would be, it would be 2 sine of 2t because of the chain rule, right? The derivative, I would do derivative of the outside function is negative sine, the negative makes it positive. Keep the inside function the same as 2t, then multiply by the derivative of the inside function, derivative of 2t is 2. All right, so the derivative of negative cosine of 2t is 2 sine of 2t. Now, if I want to get rid of this constant, all I have to do is put the reciprocal of it in front of the function. So what's the derivative of negative 1/2 cosine of 2t? Well, that would be, I'll just keep the negative 1/2 on, and then say the derivative of cosine of 2t is negative sine of, keep the inside function the same, times the derivative of the inside function, which is 2. Now the negatives cancel, the 2 and the 1/2 cancel, and I just get sine of 2t. So I have found a function whose derivative is sine of 2t, and that's what we mean by the antiderivative of sine of 2t. So that's what that is. So basically, like when you have this inside function, and it's just linear, right? It's just 2t. Well, I know that the derivative of that inside function is going to be 2. So what I do is I just put a 1/2 out. So what you can do is take the derivative of the inside function and multiply by the reciprocal, as long as the inside function is linear, all right? So yeah, sometimes I think of it like this. I think I can write this like this. So this is going to be, I'm going to keep my 13.2 out, and I'm going to say this is the antiderivative of negative 1/2 cosine of 2t evaluated from 0 to pi. So one way I can think of this is it's like a chain rule, but instead of multiplying by g prime, I multiply by 1 over g prime. Now there's actually a lot more to dealing with an inside function than that, unless the inside function is linear. It doesn't have any power of t, it's not a square root or anything weird like that. It's just ax plus b. Then you can just do 1 over g prime and multiply that, and it's going to be your antiderivative every time. All right, so let's finish this up. So let's see, then what I would do, a good thing to do in a situation like this, when I got an evaluation, it's got a constant in it, let's pull the constant out before we do the evaluation. So then 1/2 times 13.2 is 6.6. So what I'm going to have out here is negative 6.6. And then it's the evaluation of cosine of 2t from 0 to pi. So that is negative 6.6 cosine of 2 pi minus cosine of 0, right? Subbing the pi, subbing the 0. It's really 2 times 0, but okay. And that's negative 6.6 times 1, cosine of 2 pi, and cosine of 0. Well, 2 pi and 0 are coterminal angles, so it didn't matter even what trig function was in here. These two had to be the same. I had to get 0. It equals 0. All right, so the displacement is 0. Now, that makes sense if you think about this velocity curve. We went to the right, and then we went to the left. It's clearly the same area in both places, so this piston ended up at the same place that it started. So if I think of just the piston, that piston went to the right, and then it came back and ended up in the exact same place it started. So displacement is 0. So we kind of knew that before starting. All right, so that is displacement. Next, let's see if we can set up the integrals for total distance.